That's the lychee logo. The slides are pink, but you'll be in for 30 minutes of mystery because it's actually a very, very tedious, very terrible topic. We talk about the web. Actually, we talk about the brokenness of the web. The talk is actually called "So You Can Write a Link Checker in a Weekend." And I'm Matthias. I'm a Rust consultant from Düsseldorf. And I have a list of static analysis tools. It's a long, long list. There's a lot of tools. I started with that list a couple of years ago. And as you can guess, a lot of these links keep breaking. So I decided to do something about it. And I wrote a link checker. I tried to do it in a weekend. What I had in mind was, hey, let's live code it. I had a YouTube channel called Hello Rust for a while, and this is part of it. At the end of the week, and I had something workable, and it checked my links. But of course, I was not done. I was kind of happy with the results. So here you can see how this thing works. It supports various formats. You can tell it to dump links, all the links from a website. You can tell it to check all the links from README. You can store the output as JSON and lots of other things. It's a link checker. Very exciting. Now, of course, if you ever wrote a project, you know that there's more work to be done than people expect. This is a website from Daniel Stenberg. He is the author of curl. Probably everyone knows curl. Raise your hand if you know curl. Nice. This guy also had the task of building something that everyone would use, and then everyone would tell him, yeah, you can do it in a weekend. So he has an entire blog post about people that tell him all the time that it's such an easy thing to do. So I can do it in less than 100 lines. I can do it in a 3-day weekend. But what they forget is most languages use curl underneath. For example, if you use PHP, chances are you use curl, libcurl to be exact. I can build this in a weekend is what every developer says that has never built anything in a weekend. I really like that. Now, you might be thinking, why use Rust? Well, it turns out Rust is an amazing language for writing a link checker. It has native performance. It has fearless concurrency. So you can play around with various things running concurrently at the same time. It has zero-cost abstractions. So if you do it right, you don't pay for parsing. It's all in memory. You don't allocate. You have a minimal runtime. That means you can deploy it everywhere. Again, cross-platform. And it's a self-contained binary. You put it somewhere, and it just runs. But this is true for literally every single Rust project, I guess. I mean, for this specifically, we look for a very robust networking ecosystem. It should never fail. And also these things. We have a Tokyo runtime. Everyone knows what Tokyo is? Yeah, it's an asynchronous runtime for Rust. We have a production-grade browser engine called Servo from Mozilla, which we use. And we also have a production-grade, quote-unquote, Markdown parser from Google. And all of this is used by lychee, which is written in Rust. Now, I guess the task is pretty simple. We want to find broken links. Now, first, I guess, we need to define what a link is. But it's super simple. If I tell you to envision a link, then probably everyone has something like this in mind. You're like, yeah, this is what a link looks like. And that's because we're human. We're really bad at parsing stuff, or we assume that it's pretty easy for machines. That's why I want to do a game with you. I will show you something, and then you will tell me if it's a link or not. So if you think that this is a link, raise your hand. Is this a valid link? Yes, it is. How about this one? Show hands. Yes, it still is. Or at least it depends. So it doesn't have a scheme. And if you type it into a browser, it will work because your browser, which is Firefox, of course, will know that you want to maybe check https example.com. www, by the way, is just a subdomain. It's a convention. How about this? Is that a valid link? Raise hands if you think this is a valid link. We have a very bold one down there, but it's not actually, because the scheme is missing. What about this one? Yes, this is a valid link because obviously it's a protocol relative link. That means if you are on a website and you open the website with https example.com and you have / example.com, then it will use https as well. And if you open the website with HTTP, it will use HTTP. And this is nice if your website supports both. Then you can just say, use whatever protocol you used to connect with me. Is this a valid link? Yes, it is. How about this one? Okay, okay. Do you always lift your hand, or is it just, do you really believe this is a link? Awesome. Yeah, localhost is a valid example for this. What is localhost? Localhost is a convention. Where does it come from? From your etc hosts file. So if you put something into your etc hosts that can resolve to example, then this will be valid. Now, of course, that's cheating because obviously you would have to do that manually. Who does that? But this exists. So if you go to open your browser and you type AI, probably you have to type AI/, then it will show a website because this is a TLD website. Turns out if you buy a domain and then you decide to host something on the root of this TLD, then your browser can resolve it. And I guess no one would have guessed that this is a valid link. Now, I guess what we can establish is a link is everything or nothing, but at least it's always ASCII. Right. Unless you count emojis. Now, it turns out that there are TLDs which support emojis. One of them is WS. Do you know what this resolves to? Where do you go if you open this in your browser? It's a nice marketing website. Take a guess. What could it be? Oktoberfest? Yeah? Love beer? Well, someone at Budweiser was extremely smart to register that domain. I really like that idea. Not that you could ever type it, but I still like it. Now, how does it work? In the background, they use Punycode. They translate it before they resolve the website. So technically, it's not Unicode. Technically, it's not emojis. It's ASCII, but still, there's a way to resolve it. Same with umlaut domains, österreich.at. I don't know if that exists, but it should. What about this one? Yeah, that's Arabic. It says Arabic, I guess. And this is also valid, or at least it used to. Same idea, Punycode. It turns out there was someone that wrote a list of all the TLD with A records. This is what it's officially called. And they just check regularly if there's something resolvable on these TLDs. And Arabic is on the list. That's fun if you want to parse links, because our task is to parse broken links. And in order to find links, we have to know about all of these edge cases. Okay, maybe you think I can still do it in a weekend, but then there's this other thing. This is a valid link. I don't want to go through all of the details here, but it turns out that you can do a lot with URLs. Starts with a scheme, username, and then password and so on. So there's an entire blog post. I linked it below. Check it out. It's a fun read. But it can also be dangerous. Why? Anyone see the broken link? Where is the exploit? Yeah. Basically, yeah, something like that. I wasn't cheating. You can even see it. There's a difference. You have to have very keen eyes, eagle eyes. Where's my man in the back? Guy with the white t-shirt. There we go. No, actually, it's the slash. You see the slash? The slash is different. It's a bit more tilted. First one is the divide sign. The second one is the normal path. Jesus. So if you click on the first one, this will be an exploit. And I mean, we all know that we shouldn't click on links that we don't understand, but I'm pretty sure that I could even trick a couple people from Dynatrace to do that. That's all because Google decided that .zip is a nice domain name. Let's register that. Emails are easier. Mail@example.com. Everyone has an email address like that, right? Emails are easy, right? Right? Well, same problem. This could work if you decide to register an MX record on your TLD, similar to the A record that we saw before. Turns out that the .tt has something like this, so you could have a mail address like example@tt. No one would ever send you emails like this. That would be ridiculous. And the list is long. It's terrible. But, you know, you can add quotes. You can add 123, 123, whatever. IP addresses, everything goes. But one thing is for certain there. There's always the @ We can count on the @ So this is how we can discern between URLs and emails. Unless Medium decides that they want to have that in their path. And then we're royally screwed because, as you know, slashes are fine in email addresses. How do you ever parse that? Okay, this is what we're dealing with. Lots of fun. And we only covered the first part. We only covered the links part. We haven't even talked about brokenness. What is a broken link? So if you try to explain to another engineer, hey, this is how you find a broken link on the web, you have this notion, this idea how a broken link looks like. You think you go to a page and then it doesn't load. But in reality, that's not true, right? You get a 404 maybe, so it does load, provide some content. Maybe the simplest explanation would be, if it's a 404, then it's broken. Hope everyone gets that reference. Easy. If the status code is 404, it's broken. Now, for those of you that have been on this rodeo before, it's not true. There's 404, but there's also 403. There's 4 something something. So you say, nah, in reality, you want to check if a link is not returning a 200. Well, that's also not enough because there's different 200 states as well, which some of them might be okay. You have 203, for example, or 206, which is no content. So you say everything that is not a 2XX status code. Well, that's also not true. What about redirects? That's a 300 status code. Do you handle redirects? Maybe then you say, well, okay, everything that is above 400 then. But that's not true either, because what about 5XX status codes? Okay, 5XX would be client error, server errors, not client errors. Well, then you might say, also not enough, because maybe sometimes you try again and the link starts to work. So you have a temporal component to it. You want to retry a couple times, maybe, unless it's a permanent error. And this is all great until you're at LinkedIn and it's a Monday morning and you decide to screw the world. You're like, come on, what are status codes anyway? So you decide, my status code will be 999. So LinkedIn returns a 999 status code if they don't want you to crawl the page. And I really hate LinkedIn for this. LinkedIn is just weird because a lot of people tell me that LinkedIn links are somehow broken, and I need to tell them actually it's LinkedIn's problem. So there is an exclusion in lychee, which just checks if it's LinkedIn and then just does some special stuff. The web itself is pretty weird. YouTube sends you 200, but then the video is not found. Now, it turns out the way to check YouTube links is to check the thumbnail. Because when the thumbnail is gone, the video is gone. Now, in lychee, there is a check which says, is this a YouTube link? Then check the thumbnail. But don't always check blatantly the YouTube thumbnail, because YouTube has a lot of pages which are not videos, and you want to check them normally because they, for some reason, work. So to verify that, here's a curl request for a YouTube link, and here's a similar curl request for a YouTube link. If you spot the difference, you're pretty good. There's just one character at the end, minor, small q or big Q, and one video does exist and the other does not. But Twitter is like, hold my beer. I can do it even better, because they decided that Twitter will cut off all the tweets from getting read by fetching a URL. You need to be authenticated and you need to have JavaScript. There used to be a workaround, which was to use the Googlebot user agent, because for SEO reasons they allowed it. But also this doesn't work anymore. And then there used to be a different alternative called knitter.net, which allowed you to open links without being logged in, which is nice. We used that for a while, but then it got even worse. It was a bit of a nightmare, to be honest. And eventually they decided to close down and lock down, and now you have to have an account no matter what. And even Knitter is struggling. That means we had to disable Twitter. Yes, it's very sad. These are the problems that you will encounter a lot. Does anyone know what that is? DOI link? Ever heard of a DOI link? Academia. Probably some of you have studied. Maybe you read a paper once and they sometimes have DOI links because the idea is that they should never break. It's like a unique identifier for a research paper. And turns out they break. And someone sent me an email once and said, hey, I like your tool, but those links are broken. Turns out these are DOI links. What can I do about it? And I told him, okay, nothing I can help you with. It seems like they are legitimately broken. And in order to fix it, you would have to find out who maintains the DOI server. So the way DOI works is every university or every library can register to be a server of DOI links, and then they are responsible for their infrastructure. You would have to literally go to every single DOI instance and tell them that their server is broken, which is exactly what he did. So he went and he's still sending emails to people, for example, to wiley.com, who is one of the maintainers of DOI links, and he says, in capital letters, your DOI infrastructure is broken. I really like that guy. He's very persistent. Awesome. We covered brokenness, we covered links. We're done. Unless there are some edge cases. And there are plenty of edge cases. How would you parse inputs? Let's look at this. We all learned how to write HTML in a text editor, I guess. unless you're as old as me and then probably use something from Microsoft back in the days. But the beauty of the web is that you can start writing text and then see it on the web. And even if you make a mistake, for example, you forget the end angular bracket, it's gonna be fine. Your browser understands it. That's a nice feature, but it's a nightmare to parse. Because our browsers are extremely permissive. They allow you to not only do this, they also allow you to end a tag with a completely different tag. It's still gonna be fine. And that is my arch nemesis, browsing various inputs. This is an example from Markdown. Someone just recently said, this gets detected as a valid link. I hope you all see that it's not, or it shouldn't be. That's a math equation inside Markdown. Well, parsing error. And if you're the maintainer of a link checker, then this is your life. Yeah, this is me at 2 a.m. looking at the issue. Yeah. Another problem that you will hit is too many requests. Turns out lychee gets used a lot. We get to that in a second. And GitHub doesn't like lychee being used so much because turns out if you check a GitHub repository, you have a lot of GitHub links. So we hammer the servers and we run into those too many request issues a lot. What can you do about it? Well, if you want to be a good citizen of the web, it's very easy. There's a standard for that. Every website, every API sends you headers. Those are rate limit headers. That's the IETF proposed standard. Now, what you should do is just parse these headers, wait for the given time, for example, in this case, 600 seconds, and then continue parsing. Easy. You have 100 pages that you can request. You have 50 remaining. And once you're done, you wait for 600 seconds. Easy. Well, unless you read it. And then you say, come on. IETF is not standardized yet. It's a proposal. I will use my own standard. I will use X minus rate limit. Or you are at GitHub and you say, nah, it should be lowercase. And the reset time should actually be a Unix timestamp. And then GitLab says, yes, you were onto something here. I really like this idea. Actually, it should be uppercase, though. Let's add one more observed header. And also, the reset time should be in milliseconds. Or you are at X or Twitter, and then you do everything lowercase again. And you also use the same time format. So then your parsing becomes case sensitive. Well, I wasn't sure about the standard. So I wanted to look it up. There's two more formats. Vimeo decides to use this state format. And Akamai said, I like it, but let's just change the date format again. But if you want to stick to the standard, use the IETF. There's a standard for it. And I implemented the standard. That's the implementation. Turns out I was the first one to even write any library in any language that I found to parse rate limit headers for some reason. I wonder why. I wonder why, really. But you can parse them. It's not integrated into lychee yet, but I plan to. And if you want to look up the standard, just go to the website. That's the official website. Okay. Well, what do you do if, for some reason, the page does not send you those headers? And it turns out many pages don't. In this case, you can still use something like a small little algorithm for it. It works like this. You have a bucket, and there's X coins in it. In this case, there's 6 coins. And every time you make a request, you take 1 token out. And the bucket gets filled up at a fixed rate. And this is how you do rate limiting. That's the token bucket algorithm. There's a couple alternatives too. And this is pretty simple. But you would have to track every single website. So every single host would have to be tracked like this. which is really nice. But then where do you start? How many requests do you send with your first batch? 1, 10, 100? Do you ramp up? Do you not ramp up? Depends. Bot detection is another problem. Cloudflare hates crawling. You need website fingerprinting to get around this. Firefox decided to impersonate, actually curl decided to impersonate Firefox and mimic the TLS handshake, because this is how bot detection in Cloudflare works. And then even if you cover all of this, you need to handle JavaScript, because the majority of the web only works with JavaScript. This is Google without JavaScript. Looks pretty legit. You get search results. Google does a really great job here. Kudos to the guys from Google. Amazing. I like that their websites work without JavaScript. Unless you use Google Maps, of course. Then you need JavaScript, because they just keep you for a full. Well, that's much better than what Twitter does or what Bing does. This is all that Bing loads. Ask me anything. You can ask it anything. It's just not going to answer. I mean, every company does it differently. I really like how Facebook handles it, honestly, because they just declare the feed. I think this is the cleanest feed I ever had on Facebook. So maybe that should be my normal way to browse Facebook nowadays without JavaScript. I really like it. It's much better. It loads fast. So JavaScript is a bit of a problem. We went from rendering HTML with JavaScript because HTML was too slow. And then everything is in JS, but it's too slow, so we pre-render HTML. And then we pre-render all HTML, but that becomes too slow. So we render some pages on request, and then suddenly we render HTML on request again. So we went full circle for some reason. Sometimes unnecessary. And definitely a problem for people like me that want to build tools. Recursion. Say you want to check a website, has a million sub-pages. When do you stop? You can set a threshold, maybe 100 pages down. You have to keep track of that. But there's more. What if the server never responds? When do you give up? What if the response never stops? Do you ever stop? Like, it sends you 1 byte per second forever. What if the server sends no Unicode? Can you handle non-Unicode character sets? What if you read a 1 terabyte file? So lychee supports reading websites, but it also supports reading from disk. And there are big files. And if you read a 1 terabyte file or a 1 petabyte file, at some point you run out of RAM. So you cannot parse the entire thing and then load the links from it, because you won't get to that point because you cannot allocate. And even if you can do that, what if you read a 1 terabyte line? You cannot parse it line by line. You have to yield links as you find them. What if you read a 1 terabyte link? Well, that's another problem. And this is the famous iceberg. Try to summarize everything that we talked about and a couple other things. There's a lot of edge cases. A lot of edge cases. I'm almost done. This is the architecture. It's a bit big for a CLI tool. On the top, you have a collector. Collector collects links, and the extractor extracts links. And it can extract links from HTML, from Markdown, and from pure text. And for HTML, we use HTML5ever, which is the engine from Servo. And we also use HTML5 Gun, which is a bit more performant and state-based. There's this thing on the right, which is a fragment cache. Just real quick, if you don't know what fragments are, these are fragments. They're the things that are anchors or IDs. We call them fragments. That's the correct term, actually. Those get parsed, and they get stored in a cache. Because if you find them on a different page, you want to make sure that the fragment exists. Same for Markdown. Markdown can have fragments too. And plain text cannot. Now you have a bunch of links, and then you run it through the below pipeline. You create a client. We use request, and we use the GitHub API. We remap, so that means you can do various remapping. For example, you have a production website and you have a stage website or like a localhost website. You can remap from production to localhost, and every link that you find will be remapped automatically. We filter, you can exclude things based on regex and whatever. We apply some quirks, the quirks that you saw for LinkedIn, for YouTube, and so on. And then we run a check. And the check can either access the fragment cache and see if the fragment is there, or use request or Octocrab, which is our GitHub API client. You can set a GitHub token to get way more requests on GitHub. And all of this gets retried a couple times with some logic. I will get to that in a second. Well, I guess we are talking about Rust, so of course we have to cover this part. Is it fast? Is it fast? In comparison to what? I tried to do a benchmark, very scientific. At the bottom, you see I check 1,500 links max, which is nothing. But the reason is not lychee, the reason is other tools. Because you see a couple zeros, this is when the other tools stop. And by stop, I mean, I waited for 30 minutes and they just never came back with an answer. There are tools out there which cannot check 50 links. The one that is sort of decent is called lychee. It's written in Go. And lychee is just slightly faster with that many links. Lychee supports files where lychee does not. And it's also better if you have way, way more links. But at the same time, I wanted to make it comparable to the other tools. So it is fast. And why is it fast? Well, because everything is async. I talked to Ivan yesterday, asked him, hey, should I show some Rust? And he was like, yes, you need to show some Rust. And I told him, the Rust code is boring. It's really boring. He said, more Rust. You need to show more Rust. It's a Rust meetup. So I will show you some Rust code. But actually, in reality, it's really boring. This is maybe one of the more exciting parts. And even that is boring. So what do we do here? Magic. We use a stream. Everyone knows what a stream is. Okay. We return an impl stream. That means we use impl_trait. Impl_trait is a way to statically say at compile time that your return value will be of type stream, where item is result request. And with that, the compiler can optimize that, and we don't pay any runtime overhead, which is great. And we also don't have to tell it the type, fully the type. Because in reality, impl stream can be very long. If you know about futures, it can be tricky to write it down even. Now, we guarantee it to return a stream of requests. And the way we do it is we parse contents, and then for each content file, we do the thing below. We send it to a worker. There's this thing here, not this, here. That's kind of the magic sauce. Par then unordered. There's a library for that. I actually quite forgot the name by now. Stream, what is it called? Iter stream or something like that. And they have a streamExt extension trait. And an extension trait is something that you can attach to any type to extend its functionality. It's like a battery pack or a jumper pack for your type. And what it does is it attaches something to our iter method, and then we can run par then unordered on it. The non-parameter is the params for the workers, and we just pass the input through it. And this way, it spawns up a couple workers. By default, it uses 2 times the number of cores on your machine. So more or less the optimal number with hyper-threading. And then it runs the checking in the background on these worker threads. So they never block. That means you can run a lot of links, like 60,000, 70,000, depending on your network connection at once. And you won't see any CPU usage really, because that's the kernel just doing the work. So the lychee process itself will be extremely bored. It's just sending all the requests to the network card, and then it just waits for the results to come in. I guess if there is anything cool about this project, maybe it might be this. Maybe something that you can use for your own projects. I really like that library. Maybe a small joke. I read that yesterday. I really like it. Tokyo, futures, async await, walk into a bar. They pay, they leave, they drink, they order. Thank you. I'm here all day. Ivan said, we need more Rust. We need more Rust. So I said, okay, let's do one more example. That's an extension trait we have ourselves. It's called retry_ext, and it only has a single method, which is nice. I like my traits to be very small, and it only has a should retry method, and it returns a pool. Why do we have that? Because lychee supports many libraries to check links, and they have different ways to handle edge cases. So for example, we support request, we support hyper, we support octo, grep, and whatever. For example, here is the implementation of retry_ext for request response. And what you can do with this trait is you can say, you have a response, and then you can say dot should retry. And you can use it in a condition. You can say if response should retry, and all the logic is hidden behind this extension trait. So use extension traits. I'm a huge fan. For example, we check the status, and if the status is a server error, we retry. And if it's a client error, and it's not a request timeout, or it has too many requests, then don't retry. Else, if it's a success, don't retry, of course. Or finally, if the status is request timeout or request too many requests, that's when you should check for validity. And if this is the case, then retry. Yeah, if you don't get the logic, it's fine. Actually, there's more. This is the other part for checking the error, not the response from request. There's a couple things that we do here too. Check if we ran into timeout and whatever. Yeah. Lychee is used by a lot of companies. You might not know by the number of stars. It only has 1,000 stars. And Abu gave me the 1,000 star just before this, and I told him that I will mention his name, so thanks, Abu. It is used by Google, AWS, Azure, HashiCorp, CNCF, Honeycomb, OWASP, Supabase, MariaDB. Lots of companies. And it also checks a lot of links. That's actually quite an old number. I haven't checked in a while, but that's my recent estimate from the public repositories. But I know a lot of people that use it in their own private thing. Critical infrastructure. Is lychee critical infrastructure? I don't think so. There's more important problems. But I also want to raise awareness to this problem in open source. A lot of modern digital infrastructure depends on a lot of small developers like me that maintain these little things, and they don't really get any compensation whatsoever. Does anyone still know this page? That dates me. Ivan's nodding. Nice. Like 10 years younger than me, but you still know that. You're a bit of a nerd. So this is the $1 million homepage. Every pixel costs $1. That's 1 million pixels. Pretty smart idea. Was sold out real quick. People paid for these links. How many do you think are still available? I was surprised. There's a website that checked that, did some research on it. Amazing. A lot. The green stuff is still available after so many years. So maybe you don't need a link checker after all. If that's the real problem, like why? Why do this work? But in reality, you know how it goes. These are the valid links. And a human would not think that these are the real pages that were there before. There's like parked domains, weird blocked stuff. Cyber folks, I really would like to know what they did, but yeah, they are dead. That's unfortunate. it turns out that 50% of all cited links in the Supreme Court are invalid by now, and 70% of cited links in academic legal journals. And that's a huge, huge, huge problem, because we lose knowledge. That is critical infrastructure for sure. And even the Wayback Machine is struggling. The Wayback Machine is a page that archives the web. You should donate. They do an amazing thing. They archived 808 billion web pages. And they describe what they do on their page. And there's a link up here. They compare themselves to the Library of Alexandria, which I think is a fair comparison. So I wanted to learn more about that. Clicked on the link. So, yeah, that's life. There's a website called perma.cc. It's sort of a research combination. You can apply there too, similar as for DOI links. They allow you to host stuff there. They kind of, yeah, take snapshots of pages. But even that, broken. That's a GitHub issue from the open source project from Permo. And it says link to library partners on website is dead. Pretty bad. And I guess this is the point. You are an open source developer. Lots of companies use your project. Maybe, if you're lucky, you get a star. But nothing else. I guess, fortunately, there's still academia. A year ago, some team from Switzerland reached out, led by Professor Olaf Zimmermann. They are from Switzerland, and they asked me if I want to participate in a research project. So Benny and Thomas, they did their bachelor's thesis on link checking, and they used lychee for their comparison, which is really great. Got a lot of nice contributions from them. So big kudos. And if you think that you want to build something valuable from your open source project, I guess then you have to take it into your own hands. The idea that I have right now is to build something called a lychee server, which you can host yourself, and then you can connect all of your repositories or your websites, and then send reports to it, and you get a dashboard of all the broken links. And this way you find out where the most broken links are, and maybe at the end you can also fix them automatically with a pull request. That would be the idea. Yeah, that's all I got. Thank you very much.